Commander Richard Blount watches the depth gauge move past the red line, knowing that the mathematics of survival have just expired. It is May 14th, 1963, 400 miles off the coast of California, and the USS Permit is descending into a crushing darkness where American engineering has never ventured. As the hull begins to scream under the weight of the Pacific, the crew realizes they are no longer fighting the Soviets, but the laws of physics themselves. The control room of a nuclear submarine is usually a place of hushed, rhythmic efficiency, a sanctuary of cool air and soft lighting designed to separate the men inside from the hostile environment outside. But at 900 feet beneath the surface of the North Pacific, the illusion of safety has evaporated. The air is heavy, saturated with a strange, metallic humidity that tastes of copper and fear. The silence that typically governs the boat has been replaced by a sound that no training manual describes. It is not the sharp, percussive popping of a hull settling into the deep, a noise familiar to every submariner. It is a sustained, high-pitched shriek, a continuous vibration of steel compressing under a load of 4,400 pounds per square inch. Commander Richard Blount stands near the periscope stand, his hand resting lightly on the stainless steel railing. He does not grip it. To grip it would betray anxiety, and in the claustrophobic ecosystem of a submarine, the captain's anxiety is a contagion that spreads faster than fire. He watches the depth gauge, a simple analog dial with a white needle moving steadily clockwise. It passes 900 feet. It passes 910. The orders were to level off, to stabilize the boat and establish a trim. But the needle does not stop. It does not even slow down. In the sonar shack, a cramped compartment forward of the control room, the world is defined by audio. The sonar operators, men trained to distinguish the biological click of a shrimp from the cavitation of a distant propeller, are pressing their headsets against their skulls. They are hearing things that do not make sense. The active ping returns are lagging. The acoustic signature of the water itself sounds dense, compressed, as if the ocean has thickened around them. One operator looks up, his eyes wide in the dim red light. He reports that the water flow noise along the hull has changed pitch. It is no longer the smooth rush of hydrodynamics. It is turbulent and jagged, as if the shape of the submarine is changing as it falls. A whisper moves through the fire control party, a single word that carries more weight than the entire Pacific Ocean. Thresher. It has been only 34 days since the USS Thresher, the sister ship of the Permit and the lead boat of this new revolutionary class, vanished in the Atlantic. She had dived to her test depth and never returned, taking 129 men to the bottom. The Navy has not yet determined the cause. There are theories about piping failures and electrical buses, but no one really knows. All the men aboard the Permit know is that the Thresher is dead, and now they are occupying the same depth in the same class of shipper, experiencing the same uncommanded descent. The ghost of the Thresher is not a superstition, it is a tactical reality sitting in the control room with them. Captain Blount looks at the diving officer. The plainsmen are hauling back on the yokes, their forearms straining, trying to use the ship's speed and the angle of the bow planes to drive the boat back up. It is like trying to fly an airplane out of a stall. But the Permit is heavy. She feels sluggish, unresponsive, a 4,000-ton mass of steel sliding down a slope of water. Blount realizes with a cold, intellectual clarity that the submarine is no longer behaving according to the rules of naval architecture. The buoyancy calculations, the trim sheets, the displacement curves, they are all correct on paper, but down here, in the crushing reality of the deep, they are failing. To understand why Commander Blount and his crew are falling toward the abyss, one must look away from the depth gauge and toward the geopolitical map of 1963. The Permit is not diving for the sake of exploration. She is diving because the United States is terrified. The year 1963 sits at the razor's edge of the Cold War. The Cuban Missile Crisis is a fresh memory, a trauma that has left the American military establishment in a state of hypervigilance. While the crisis was resolved without nuclear war, it revealed a terrifying vulnerability. The Soviet Union, previously viewed as a land power with a coastal navy, has begun to move into the deep ocean. American intelligence agencies are tracking the development of new Soviet ballistic missile submarines, the Hotel and Yankee classes, that can launch nuclear warheads from the sea. The strategic implication is a nightmare for the Pentagon. If the Soviets can hide their missiles in the deep ocean, the United States loses its ability to neutralize them in a first strike or counterforce attack. The ocean is vast, opaque, and provides the ultimate cover. To counter this, the U.S. Navy needs a new kind of predator. They need a submarine that can dive deeper than the Soviets, listen further, and kill faster. They need to turn the ocean from a sanctuary into a trap. This necessity birthed the Permit class. These are not merely improved versions of the World War II submarines. They are a quantum leap in technology. The defining feature of the class is the hull material, HY80 steel. High-yield 80 is a low-carbon, low-alloy steel capable of withstanding 80,000 pounds per square inch of pressure before yielding. It is incredibly tough, difficult to weld, and theoretically capable of taking a submarine to depths that would crush a standard vessel like an aluminum can. The design philosophy is aggressive. The Navy demanded a boat that could operate comfortably at 300 feet, the test depth, and survive even deeper. This depth is critical because of the thermoclines, layers of water temperature that act as sonar barriers. If an American submarine can dive below the thermocline, it becomes invisible to surface ships and can look up to spot the silhouettes of shallower Soviet boomers. The deep water is the high ground of the underwater war, but this technological ambition has created a dangerous momentum. The political pressure to get these ships into the water is immense. If we don't go deeper, they will, becomes the mantra in Washington. The schedule is accelerated. The sea trials are compressed. The engineers are pushing the envelope of materials science, relying on theoretical models because there is no way to test the full scale of the pressures without actually going there. The USS Permit was originally named the USS Thresher. When the actual Thresher, SSN 593, was lost in April, the class name transferred to the next boat in line, the Permit, SSN 594. She inherited the name of the class, and she inherited the fear. She is the first of her kind to return to the deep after the disaster. The dive on May 14th is not just a training exercise, it is a proof of concept. The Navy needs to know if the design is flawed. They need to know if the Thresher was a fluke or a symptom of a fundamental error in the mathematics of the hull. Commander Blount knows this context. He knows that admirals in Washington are waiting for his report. He knows that the entire future of the submarine force depends on the success of this hull design. But as the depth gauge ticks past 920 feet, the geopolitical strategy evaporates. There is only the immediate physical reality of the steel tube compressing around him. The hull frames are circular ribs of steel that support the skin of the submarine. As the external pressure increases, the hull is squeezed inward. This is expected behavior. The boat effectively shrinks by several inches in diameter at test depth. But on this dive, the compression feels different. The deck plates are buckling slightly, popping against their fasteners. The stanchions are bowing. The ship feels as though it is being gripped by a giant hand that is slowly tightening its fist. Blount watches the digital repeater. 925 feet, the descent rate is increasing. The boat is getting heavier. This is a phenomenon known as compression loss of buoyancy. As the hull is squeezed smaller, it displaces less water. Less displacement means less lift. The deeper they go, the faster they fall. It is a vicious feedback loop that every submariner learns in school, but experiencing it is a different matter. The crew in the control room maintains their discipline. No one screams. No one leaves their station. They are professionals, trained to operate machinery under stress. But the silence is heavy. The quartermaster of the watch records the depth in the logbook, his handwriting jagged as the vibration of the hull transfers through the table. 930 feet. The environment inside the ship begins to change. The air pressure is stable, but the temperature is fluctuating. The seawater cooling systems, circulating the freezing ocean water through the ship to cool the reactor and the electronics, are working harder. The pipes are sweating profusely. Condensation begins to drip from the overhead cable runs. It starts as a slow drip, then accelerates. Within minutes, it is raining inside the control room. Cold water patters against the metal consoles and the backs of the crew's necks. It adds a surreal, dreamlike quality to the emergency. They are underwater, and it is raining. Blount knows he has to act. The diving planes are not enough. The speed is not enough. The ocean has a hold of them, and it is dragging them down to the crushed depth where the HY-80 steel will finally give up. He has one card left to play, the emergency ballast blow. It is a brute force solution, a system designed to inject thousands of pounds of high-pressure air into the ballast tanks, expelling the water and forcing the ship to the surface like a cork. Emergency blow, Blount orders. Main ballast tanks, forward and aft. The chief of the watch reaches for the actuating levers. These are large, red-handled controls protected by wire cages. He flips the locking wires and throws the levers up. The expectation is immediate violence. When the emergency blow is activated, the roar of expanding air usually deafens the crew. The boat should shudder. The bow should snap upward, and the sensation of falling should be replaced by the heavy G-force of a rocket-like ascent. The chief throws the levers. The valves open. There is a roar, a hiss of escaping air that sounds like a jet engine igniting in the ballast tanks. The crew braces for the ascent. They grab the handrails. They lock their knees. But nothing happens. The depth gauge does not stop. 935 feet, 940 feet. The needle continues its smooth, lethal rotation. The roar of the air continues, but the ship does not rise. The sensation of falling remains. The rain continues to fall from the ceiling. The hull continues to scream. Blount stares at the gauge. The system is functioning. The air banks are dumping their charge. But the physics are failing. The air, expanding rapidly from 4,500 psi into the tanks, is undergoing adiabatic cooling. It is freezing. The moisture in the air lines turns to ice, clogging the diffusers. The water in the tanks, pressed in by the immense weight of the ocean, refuses to leave. The air bubbles are simply compressing, providing no lift. The Permit is now heavy, deep, and blowing her air into a void that refuses to accept it. They are past the point of return. The strategy of the Cold War, the theories of the naval architects, and the courage of the crew have all led them to this single point in time and space where the machine is no longer answering the helm. They are falling into the dark, and for the first time. Commander Blount allows himself the thought that they are not going to stop until they hit the bottom. The roar of the high-pressure air banks venting into the ballast tanks is the loudest sound Commander Blount has ever heard inside a submarine, a deafening, continuous thunder that vibrates the fillings in his teeth. In a standard emergency surfacing drill, this sound is the herald of salvation. It is usually followed immediately by a violent upward lurch, a sensation of massive buoyancy, overcoming gravity, pushing the deck up beneath the crew's feet like a rising elevator. But at 940 feet, there is no lurch. There is no rise. There is only the roar and the sickening smooth sensation of a freefall that has not been arrested. Blount grips the periscope stand, his eyes locked on the depth gauge. The needle is still moving clockwise. The digits on the repeater click over with a mechanical indifference. 942, 943, 944. The submarine is consuming its own air supply, blowing its lifeblood into the sea, and the sea is swallowing it whole without flinching. In the engineering spaces aft, the situation is devolving from a mechanical failure into a thermodynamic nightmare. The emergency blow system relies on the rapid expansion of compressed air. The air is stored in banks at 4,500 pounds per square inch. When the valves open, that air rushes into the ballast tanks, which are pressurized only to the ambient weight of the ocean, roughly 420 psi at this depth. The pressure differential is immense. According to the ideal gas law, when a gas expands that rapidly, its temperature plummets. It is a phenomenon known as adiabatic cooling. As the air screams through the diffusers and the monometal piping, it drops instantly to temperatures far below zero. The moisture naturally present in the system flash freezes. Inside the intricate valve manifolds, ice begins to form. It starts as a thin rime of frost, then builds into solid plugs of white ice, clogging the mesh screens designed to silence the airflow. The roar of the blow changes pitch. It goes from a throat-clearing thunder to a strangled, high-pitched hiss. The volume of air entering the tanks drops precipitously. The lift they need to counter the weight of the ship is being choked off by the physics of the air itself. The engineering officer, Lieutenant Commander Miller, watches the frost line racing down the piping in the maneuvering room. The pipes turn white, then thick with ice. He realizes with a jolt of horror that the system designed to save them is freezing itself shut. The air banks are still full of pressure, but the path to the ocean is blocked. They are dying with their pockets full of gold they cannot spend. Back in the control room, the environment has become surreal. The condensation that began as a drip in Part 1 has transformed into a localized weather system. The hull of the Permit, compressed and chilled by the deep ocean, acts as a massive condenser plate. The warm, humid air of the ship's interior hits the cold steel and liquefies. It is raining inside the Submarine. Water runs down the faces of the sonar operators. It drips from the overhead cable runs, splashing onto the chart tables and the fire control consoles. The deck plates are slick. A fog begins to rise from the floor, a mist of cold vapor that obscures the far ends of the compartment. The red battle lights refract through the mist, turning the control room into a bloody, hazy tunnel. Through this fog, the crew continues to work. This is the discipline of the nuclear navy. There is no screaming, there is no panic, there is only the rigid adherence to procedure, even when the procedure is clearly failing. The plainsmen on the dive bench are hauling back on the yokes with everything they have, their triceps trembling, trying to plane the ship up using the forward momentum. But the Permit is heavy. She feels sluggish, like a car driving through wet cement. The hydrodynamic lift generated by the planes is insufficient to counter the negative buoyancy caused by the hull compression. In the sonar shack, the perception of the disaster is auditory. Sonar man First Class Higgins presses the headphones against his skull until the plastic digs into his skin. He is listening to the ocean, and the ocean sounds wrong. Usually the sea is a cavernous, echoing space. Sound travels, bounces, and reverberates. But as the Permit slides past 945 feet, the acoustic quality of the water changes. The echoes from the active sonar pings are returning too fast, or perhaps too sharp. The water feels thick to the senses. It creates a sensation of claustrophobia that shouldn't exist in the open ocean. "Con sonar," Higgins reports, his voice trembling slightly. "Flow noise is inconsistent. It sounds like the water is compressed around the hull." He can hear the hull talking. It is no longer just groaning, it is popping. These are loud, gunshot-like cracks that occur as the steel frames adjust to the crushing load. Each pop represents a micrometric shift in the submarine's diameter. The hull is shrinking, the frames are settling. If a weld has a microscopic flaw, a bubble of air trapped in the steel during construction, a piece of slag left by a welder in a hurry, this is the moment it will fail. Higgins thinks of the Thresher. The Navy had released a sanitized version of the acoustic data from the lost submarine. They described breaking up noises. Higgins knows what that really means. It means the sound of compartments imploding one by one, the sound of bulkheads shearing, the sound of air being compressed until it ignites. He listens to the pops of the Permit's hull and wonders which one will be the last sound he ever hears. Captain Blount wipes the condensation from his eyes. The depth gauge reads 948 feet. They are 2 feet away from the rated test depth. Test depth is a sacred number in submarine design. It is the depth at which the ship is certified to operate safely. It includes a margin of safety, a buffer zone before the calculated collapse. Depth where the hull will implode, but after the loss of Thresher, that margin of safety is a theoretical ghost. No one trusts the math anymore. The engineers in Washington calculate the collapse depth on slide rules, assuming perfect steel and perfect welds. Blount knows there is no such thing as perfect steel. He realizes that the submarine is falling. It is not driving down. It is slipping. The sensation is distinct and nauseating. It is the feeling of an elevator cable snapping, but in slow motion. The floor drops away beneath his feet, just slightly faster than his body expects. It is a mushy feeling, a lack of resistance. The ocean, which usually supports the ship, seems to have opened a trap door. "All back 2/3, Blount orders. It is a desperate move. Reversing the screw might arrest the forward motion that is driving them down, but it also kills the lift from the diving planes. It is a trade-off between speed and buoyancy. He is trying to stop the descent by brute force, using the propeller to claw at the water. The orders are relayed. The steam valves in the engine room are spun shut and reopened. The shaft slows, stops, and reverses. The propeller bites into the water, churning a vortex of cavitation. The ship shudders violently as the torque fights the momentum, but the depth gauge does not stop. 950 feet. They have crossed the line. They are now operating in the excursion zone, the forbidden territory where the warranty expires. The red needle moves into the black hash marks of the gauge. The atmosphere in the control room shifts from professional concern to a cold, paralyzed horror. The men know what 950 feet means. It means they are test pilots in a machine that is crashing. The condensation rain falls harder. The fog thickens. The groans of the hull merge into a continuous, high-frequency vibration, a singing of the steel that sets teeth on edge. The chief of the watch, a veteran with 20 years of service, looks at the ballast control panel. The lights for the vent valves are green, open. The air is still trying to flow, but the pressure differential gauges show almost no change. The tanks are not emptying. The ice has won. "No effect from the blow, Captain," the chief says. His voice is flat, devoid of hope. "Ballast tanks are still flooded." Blount looks at the digital depth detector. 952 feet. He feels a strange detachment. The fear is there, a cold knot in his stomach, but it is overlaid by intense analytical curiosity. He is watching the end of his life, and he is fascinated by the mechanics of it. He thinks about the hull frames compressing. He thinks about the adiabatic cooling. He thinks about the men in the torpedo room, forward, who will be the first to die if the bow collapses. Then he notices something on the gauge. The rate of descent is slowing. It is subtle at first. The needle, which had been sweeping steadily, begins to hesitate. It ticks. 952. Pause. 953. It stops. The submarine shudders one. Last time, a massive keel-shaking convulsion as the reversing screw finally bites into the dense water. The forward momentum bleeds off. The downward vector arrests, but they do not rise. The Permit hangs, suspended in the dark. The depth gauge is frozen at 953 feet. The air banks are hissing weakly. The propeller is churning. The hull is screaming. But the ship is motionless. It is a moment of impossible equilibrium. The forces of gravity, buoyancy, drag, and thrust have cancelled each other out exactly at the point of maximum danger. They are balanced on the tip of a needle. For 5 seconds, time in the control room stops. The rain of condensation seems to freeze in mid-air. The men do not breathe. They do not blink. They are waiting for the hull to buckle. They are waiting for the ocean to finish the job. Blount stares at the gauge. He is waiting for it to move. If it ticks to 9:54, they are dead. If it ticks to 9:52, they might live. It stays at 9:53. In that 5 seconds of suspension, the crew of the Permit experiences a collective hallucination of physics. They feel heavy, pressed into the deck, yet simultaneously weightless, as if the earth below them has disappeared. The ocean outside feels solid, a vice that has clamped down on the ship and refuses to let go. They are trapped in amber, deep beneath the world, waiting for the universe to decide if they are allowed to exist. The depth gauge needle rests at 953 feet. It does not vibrate, it does not waver, it is as still as a painted line on a canvas. For 5 seconds, the USS Permit exists in a state of suspended reality. To the 112 men trapped inside the pressure hull, these 5 seconds do not pass in linear time. They stretch out, expanding into an eternity of silence that overrides the roar of the air banks and the groan of the steel. In the control room, the concept of a future ceases to exist. There is only the immediate, crushing present. Commander Blount looks at the diving officer. He sees a man he has known for years, a professional with a wife and 2 daughters in San Diego, frozen with his hand on the ballast control lever. The diving officer is not breathing. His eyes are fixed on the inclinometer, waiting for the bow to drop, for the final tumble into the abyss. In the corner, a young seaman on the phone talker circuit closes his eyes. His lips move silently. He is praying, but the words are swallowed by the heavy, pressurized atmosphere. The sensation of the ship is wrong. A submarine at neutral buoyancy feels light, responsive to the water. A submarine driving deep feels heavy, aggressive. But at 953 feet, the Permit feels trapped. It feels as though the ocean has solidified around the hull, gripping it in a vice of 4,000 pounds per square inch. The vibration of the propeller, still churning in reverse, sends a shudder through the deck plates that feels less like mechanical power and more like the desperate struggle of a trapped animal. The hull is no longer popping. The loud, gunshot cracks of the frame settling have been replaced by a low, continuous hum, a frequency just on the edge of human hearing. It is the sound of the HY-80 steel lattice vibrating under a load that approaches its yield point. The metal is singing. 1 second, 2 seconds, 3 seconds. Blount waits for the collapse. He knows the engineering tables. He knows that at this depth, any microscopic imperfection in the circularity of the hull, a dent, a flat spot, a variance in the welding will become a focal point for the pressure. The ocean will seek out the weakness, magnify it, and fold the steel inward in milliseconds. 4 seconds. 5 seconds. Then the needle moves. It does not jump. It does not jerk. It simply ticks with agonizing slowness. To the left, 9:52. The air in Blount's lungs rushes out. The collective exhale of the control room is audible, a sound of release that competes with the hiss of the ventilation. 9:50. They are moving up. The ascent is unnerving. It is not the violent, rocket-like recovery that usually follows an emergency blow. The ice in the airlines has likely cleared. Or perhaps the density of the air in the tanks has finally displaced enough water to overcome the ship's mass. But the rise is smooth, almost gentle. It feels artificial, as if a giant hand has released its grip on the keel and is slowly lifting them toward the light. 9:40. The sensation of falling evaporates, replaced by the heavy G-force of positive buoyancy. The deck angles upward, 10 degrees, then 15. The condensation rain that has plagued the control room changes direction, running aft, pooling against the rear bulkheads. "Passing 900 feet, Captain," the diving officer reports. His voice is cracked, dry, devoid of the crisp professionalism of a drill. It is the voice of a man who has looked over the edge of a cliff and stepped back. "Very well," Blount replies. His own voice sounds distant to his ears. "Reduce the up angle. Let's not broach." 800 feet. The hull begins to expand. As the external pressure decreases, the steel frames relax. The sounds return, the loud, sharp bangs of metal decompressing. But now, these sounds are welcome. They are the sounds of the ship breathing again. 600 feet. Level off, Blount orders. Establish trim. The Permit settles at 600 feet. The diving planes bite into the water, leveling the deck. The propeller shaft is stopped, then brought ahead slow. The submarine returns to a stable hover, a machine once again in control of its environment. There is no cheering. In the movies, this is the moment where the crew erupts in celebration, clapping each other on the back. But in the control room of the USS Permit, there is only a profound, shaking silence. The men look at each other with wide, hollow eyes. They wipe the sweat and condensation from their faces. They check their gauges. But they do not smile. They know how close it was. They know that for 5 seconds, the math didn't work. They survived, not because of skill or procedure or heroism. They survived because the ocean, for reasons they cannot explain, decided to let them go. The survival feels unnatural, a theft from the grave. Secure from emergency stations, Blount says. He turns away from the depth gauge, unable to look at it any longer. Rig for patrol quiet. Get the section leaders to check their men. He walks to his stateroom, a tiny cubicle just off the passageway. He closes the curtain. He sits on his bunk, his hands trembling uncontrollably. He stares at his hands, watching the tremors, waiting for his nervous system to process the adrenaline dump. Then, he reaches for the ship's log. This is the burden of command. He must write the official record of the last 20 minutes. He unscrews his fountain pen. The ink is black on the white paper. He writes the time. 347 hours. He writes the location, North Pacific Operating Area. Then he hesitates. How does he describe the scream of the hull? How does he document the rain inside the ship? How does he explain the 5 seconds where physics seemed to suspend itself? If he writes the truth, if he describes the terror, the thickness of the water reported by sonar, the sensation of the steel turning into something organic, he will sound like a man who has lost his nerve. The Navy does not like metaphysics. The Navy likes data. If he writes everything, he risks panic. The Permit is the lead ship of her class. There are a dozen more being built. If he reports that the design is fundamentally flawed, that the ocean at 950 feet is a different universe, he could paralyze the entire submarine force. But if he writes nothing, he carries the lie alone. He leaves the next captain, the next crew, vulnerable to the same trap. He thinks of the Thresher. He thinks of the 129 men who died just weeks ago. He owes them the truth. But the truth must be translated into the language of bureaucracy. Blount touches the pen to the paper. He chooses his words with the precision of a lawyer. Experienced uncommanded depth excursion during deep dive trials. Depth reached 953 feet. Emergency blow activated. Delayed recovery noted. Suspect adiabatic icing in air banks. Hull integrity maintained. He leaves out the sound. He leaves out the fear. He leaves out the 5 seconds of absolute stillness. He closes the logbook. The words are accurate, but they are not the truth. The truth is in the steel of the hull, in the microscopic changes to the crystal lattice that no eye can see. The truth is that they went too deep, and they came back changed. Blount lies back on his bunk, staring at the overhead. He knows that the Permit will have to go back to port. There will be an investigation. Admiral Rickover will want answers. The engineers will swarm the boat with their slide rules and their theories, but Blount knows something they don't. He knows that the charts are wrong. The line marked test depth is not a safety limit. It is a boundary between the known world and a place where the rules of engineering dissolve. He has been to that place. And as he closes his eyes, trying to force his heart rate to slow, He hears the sound again, the high-pitched singing vibration of the steel at 953 feet. It is a sound he will hear in his sleep for the rest of his life. The submarine moves silently through the dark, heading east toward California. But the crew walks softly. They touch the bulkheads with a new reverence. They know now that the steel is not dead matter. It is the only thing holding back the end of the world, and they have heard it scream. June 1963, Washington, D.C. The office of Admiral Hyman G. Rickover in the main Navy building is a place of austere terror. It is not decorated with medals or photos of smiling families. It is filled with binders, technical schematics, and the heavy, stagnant air of a room where careers go to die. Rickover, the father of the nuclear navy, sits behind a desk that serves less as furniture and more as a fortification. In front of him lies the logbook from the USS Permit. Rickover reads Commander Blount's entry for the third time. His eyes, dark and heavy-lidded, scan the sterile language of the report. Uncommanded depth excursion. Delayed recovery. Most admirals would read this as a crew error, a failure of training or discipline. But Rickover is not most admirals. He's an engineer first, an officer second. He looks at the numbers, 9,553 feet, and he sees a variable that does not fit the equation. He opens a desk drawer and withdraws two other files. They are stamped with red diagonal stripes. Confidential. The first file is for the USS Plunger, SSN 595. 2 weeks after the Permit incident off the coast of San Diego, the Plunger experienced a similar anomaly. At 870 feet, the diving officer reported a loss of feel in the controls, a sensation of the ship slipping sideways in the water column. 2 sailors were hospitalized for psychological evaluation after claiming the walls of the engine room were breathing. The second file is thinner. It is the preliminary loss assessment for the USS Thresher, SSN 593. April 10th, 1963. The Thresher had dived to test depth and never returned. The official Navy inquiry is leaning toward a piping failure, a silver brazed joint in a salt water line that burst, spraying water onto the electrical bus, scramming the reactor, and leaving the boat powerless. It is a plausible, mechanical explanation. But Rickover places the 3 files side by side. Thresher, Permit, Plunger, 3 ships of the same class. 3 deep dives, 3 events where the submarine ceased to behave like a machine and began to behave like a falling stone. Rickover picks up the phone. He does not dial the Pentagon. He dials the Naval Research Laboratory. "This is Rickover," he says, his voice a low rasp. "I want a team at Portsmouth Naval Shipyard by 0800 tomorrow. I want metallurgists, not admirals. I want the men who look at the grain structure of the steel, and I want the hull of the Permit stripped down to the bare metal. Portsmouth Naval Shipyard, Kittery, Maine." July 1963. The dry dock smells of wet rust, ozone, and the grinding dust of industrial sanders. The USS Permit sits high and dry on the keel blocks, a massive black cigar exposed to the harsh glare of floodlights. She looks intact. To the naked eye, her HY-80 steel skin is smooth, unbroken, a testament to American industrial might. But Dr. Martin Keller, the lead metallurgist from the Naval Research Laboratory, is not looking with the naked eye. He is looking with ultrasound. For 3 weeks, Keller and his team have been crawling over the hull like ants, pressing transducers against the cold steel. They are mapping the thickness of the pressure hull inch by inch. What they are finding is impossible. According to the design specifications, HY-80 steel is elastic. It compresses under pressure and springs back when the pressure is released. It is a spring. But the data from the Permit shows something else. Keller stands on the scaffolding, adjusting his calipers. He measures the hull plate at frame 47. It is thinner than the blueprints specify. Not by much. Mere fractions of a millimeter. But enough. The steel has compressed, but it has not fully rebounded. It has changed shape. It has memory, Keller whispers to his assistant. The metal remembers where it's been. He climbs down and walks to the mobile laboratory set up on the dock side. Inside, electron microscopes are scanning core samples taken from the Permit's hull. The images on the green phosphor screens reveal the terrifying truth of what happened at 953 feet. In a standard sample of HY80 steel, the crystalline structure is a rigid, orderly lattice. It is a grid of iron and carbon atoms locked in place. But the samples from the Permit look different. The lattice is distorted. The grain boundaries, the lines between the crystals, are twisted, flowing like currents in a river. Keller realizes he is looking at a phenomenon usually found only in geology, in the deep rocks of the Earth's mantle. It is a phase transition. Under the extreme pressure of the dive, combined with the microscopic imperfections in the alloy, the steel did not just compress, it reorganized. The atoms unlocked themselves and slid into a new, denser configuration to survive the crushing weight of the ocean. The hull didn't just resist the water, it adapted to it. It became, for a few seconds, a metastable material, something halfway between a solid and a liquid. This explains the screaming reported by the crew. It wasn't friction. It was the sound of the crystal lattice shattering and reforming at the atomic level. It explains the sluggish feeling of the ship. The hull was literally shrinking faster than the buoyancy calculations could account for. The Permit had entered a physical state that naval engineering did not know existed. But why did Permit survive? And why did Thresher die? Keller pulls the file on the Thresher's construction. He spreads the blueprints out next to the microscope images. The answer is not in the steel itself, but in how the steel was joined. The Thresher was the first of her kind. Her construction was rushed. To save time and money, the Navy had allowed the shipyard to use silver brazing for the saltwater piping joints instead of welding. Brazing is essentially high-strength soldering. It relies on a thin layer of silver alloy to bond two pipes together. Keller runs the simulation in his mind. April 10th. The Thresher descends to test depth. The pressure mounts. The HY80 hull hits the critical threshold. The phase transition begins. The steel lattice unlocks and shifts, the hull shrinking violently by inches in a fraction of a second. On the Permit, the pipes were welded or secured with newer, flexible mounts. The ship flexed, groaned, and held. But on the Thresher, the silver brazed joints were rigid. When the hull shifted, the joints didn't flex. They sheared. Keller sees the catastrophe unfold in his imagination. A 3-inch saltwater pipe snaps in the engine room. Water enters at 2,000 psi. It sprays across the engine room, a mist of electrified salt water. It hits the main electrical switchboard. The reactor scrams. The propulsion dies. The Thresher is heavy, deep, and powerless. The captain tries to blow the ballast tanks, but the air banks freeze just like on the Permit. The hull continues to compress, continues to shrink, continues to fall. The Thresher didn't just leak. She was crushed by her own skin-changing shape. The men inside were victims of a physics experiment they didn't know they were participating in. Keller feels a wave of nausea. He isn't looking at metal anymore. He's looking at a tombstone. He picks up the secure phone to Washington. "Admiral Rickover," Keller says when the line clicks open. "I know what happened, and I know why." Washington, D.C., the conference room. The silence in the room is heavier than the pressure at test depth. Admiral Rickover sits at the head of the table, his face a mask of granite. Around him sit the heads of the Bureau of Ships, the shipyard commanders, and the naval architects. They have just heard Dr. Keller's presentation. They have seen the microscope images of the twisted steel lattice. "So," Rickover says, his voice quiet and dangerous, "you are telling me that we have built a fleet of submarines using a material that becomes unstable at the very depths we ordered them to operate." Not unstable, Admiral. A naval architect interjects nervously. Metastable. The steel holds. It's the fittings that fail. If the construction is perfect, the ship survives. Rickover slams his hand on the table. The sound is like a gunshot. Perfect? He snarls. There is no such thing as perfect in a shipyard. You are relying on a welder named Joe who has a hangover on a Tuesday morning to make a weld that defies the laws of physics. You're betting the lives of 100 men on the idea that every single silver brazed joint is flawless? He stands up, pacing the room like a caged tiger. We have been gambling, Rickover says. We pushed the technology faster than our understanding. We built the Thresher and the Permit to fight the Soviets, but we forgot to fight the ocean first. He turns to the window, looking out at the Potomac. He thinks of the 129 men of the Thresher, drifting in the dark. He thinks of Blount and the crew of the Permit, hanging at 953 feet, waiting for the end. It stops, Rickover says. Today. Sir? The Permit class is grounded, Rickover orders. All of them. Permit, Plunger, Barb, all the boats currently on the ways. They do not dive. They do not leave the pier. Admiral, the strategic implications. A representative from the Pentagon starts. The Soviets are launching their new Yankee class. If we stand down the fast attack fleet now, we leave the Atlantic wide open. I don't care if the Soviets are sailing up the Potomac, Rickover shoots back. I will not send another American crew to die in a machine that we do not understand. We are going to tear these boats apart. We are going to rip out every brazed joint and replace it with a weld. We are going to X-ray every inch of the hull. We are going to document the pedigree of every valve and every bolt. He leans over the table, his eyes boring into the men who signed the checks. We are going to create a new standard. No more probably good enough. No more theoretical margins. We are going to have absolute objective proof that the ship will survive, or the ship does not sail. This is the moment of conception. In the ashes of the Thresher and the terror of the Permit, a new doctrine is born. It will not be a weapon system. It will not be a new reactor. It will be a philosophy of engineering. Rickover writes a phrase on his notepad. SUBSAFE. We are going back to the drawing board, he says. And this time, we are going to listen to the steel. The meeting ends. The orders go out. The Cold War pauses. At least for the United States Navy. The race for depth is over. The race for quality has begun. But for the crew of the Permit, waiting in Portsmouth, the order brings a different kind of chill. It confirms what they felt in their bones at 953 feet. They had survived the impossible, and now they were being asked to wait while the Navy figured out how to make sure they never had to do it again. Portsmouth Naval Shipyard, Kittery, Maine. August 1963. The reconstruction of the USS Permit is not a repair job, it is an exorcism. The submarine sits in the dry dock, her hull opened up like a patient on an operating table. The air is filled with the blinding blue-white light of arc welders and the scream of grinders. But unlike the frenzied pace of her original construction, there is no rushing now. The tempo has changed. It is slow, deliberate, and obsessive. Commander Richard Blount walks the scaffolding alongside Dr. Martin Keller. They are watching a team of pipe fitters remove a section of the main seawater cooling loop. In the old days, 6 months ago, this would have been a simple swap. Now, it is a forensic procedure. Every valve, every bolt, every foot of pipe being installed comes with a pedigree. It is a dossier of paperwork that traces the metal back to the foundry where it was cast. It lists the name of the miner who dug the ore, the temperature of the furnace, the chemical composition of the alloy, and the name of the inspector who stamped it. This is the birth of objective quality evidence. It is the core tenet of Admiral Rickover's new religion, SUBSAFE. Rickover's philosophy is brutal in its simplicity. The ocean does not forgive hope, it only respects proof. If you cannot prove, on paper, with signatures and X-rays, that a joint will hold, then the joint does not exist. Blount watches as a silver-brazed joint, identical to the one that killed the Thresher, is cut out. It is replaced by a heavy, full-penetration weld. An inspector immediately steps in, applying dye penetrant to check for surface cracks, followed by an X-ray team to check for internal voids. If a single bubble of air is found in the weld, the entire section is cut out and done again. "It feels heavy," Blount says, looking at the thickening web of documentation binders that accompany the ship. "It is heavy," Keller replies. "We are replacing luck with data. Luck is light. Data weighs a ton." The ultimate test comes in late August. It is not a sea trial. It is a tank test. The engineers have constructed a massive hyperbaric chamber on the shipyard grounds capable of holding entire sections of the submarine's piping systems. They load a rebuilt section of the Permit's ballast system inside, the very system that froze and failed at 953 feet. They seal the chamber and begin to pump water in. They do not stop at 1,300 feet. They push the pressure to the equivalent of 1,800 feet. Inside the tank, the pipes groan. The steel compresses. But this time, the engineers are watching. They have wrapped the pipes in heating coils to prevent adiabatic freezing. They have redesigned the diffusers. At maximum pressure, the system holds. There is no screaming metal. There is no failure. The physics have not changed. The pressure is just as crushing as it was in May. But the engineering has finally caught up to the reality of the environment. North Atlantic. Operating area. February 1964. The Atlantic Ocean. In winter is a gray, heaving wilderness of 30-foot swells and freezing spray. The USS Permit labors on the surface, rolling heavily. She looks the same as she did a year ago, a long black silhouette against the whitecaps. But she is a different ship. She is heavier, denser, and carrying a library of documentation that certifies her right to exist. Commander Blount stands in the control room. The crew is largely the same men who fell into the abyss 9 months earlier. They're older now, in the eyes. They move with a quiet economy of motion. There is no bravado. They know what is waiting for them down there. "Submerge the ship," Blount orders. The vents open. The ocean rushes into the ballast tanks. The Permit slips beneath the waves, leaving the turbulence of the storm behind. They descend to 400 feet. The hull pops, a sharp, loud bang that makes a junior officer jump. "Frame 42 settling," the chief of the watch says calmly. He marks it in the log. He knows it is frame 42 because he has seen the X-rays of frame 42. He knows the grain structure of the steel. He knows it will hold. "Make your depth 800 feet, Blount says. The deck tilts. The digital depth repeater begins to click. 600, 700, 800. At 800 feet, the hull begins to sing. It is the low-frequency vibration of the HY-80 steel compressing. 9 months ago, this sound was the prelude to terror. Now, it is just data. Dr. Keller's team has mapped the harmonic resonance of the hull. They know that the singing is the metal storing energy, not failing. "Level off at 800, Blount orders. "Check trim." The diving officer makes a micro-adjustment. The ship responds instantly. The mushiness, the sluggish, falling leaf sensation of the previous dive, is gone. The control surfaces are biting into the water. The hydraulic systems, now reinforced and heated, are delivering full power to the planes. Blount looks at the depth gauge. The needle is steady. "Captain," the executive officer says, "we are ready for the deep dive." This is the moment. They are going back to test depth. They're going back to the line where the Thresher died. "Take her down," Blount says. "Test depth. 1,300 feet. The plainsmen push the yokes forward. The floor drops away. 900 feet. The control room is dry. There is no rain. The new insulation and dehumidifiers are scrubbing the moisture from the air before it can condense on the cold hull. The fog is gone. The red battle lights shine clear and sharp. 953 feet. Blount watches the number tick past. 9:53. The depth where they stopped falling, the depth where they hung in the balance for 5 seconds. It passes without drama. It is just a number now. 1,000 feet. The pressure outside is 445 pounds per square inch. The hull is shrinking by nearly an inch in diameter. The main steam lines in the engine room are flexing in their new mounts. 200 feet. The groaning of the hull is constant now, a heavy, grinding protest. But it is a controlled sound. It is the sound of a machine doing exactly what it was designed to do. 300 feet, the diving officer reports. Test depth attained. Level off, Blount commands. The Permit levels out. She hovers in the black water, a mile above the bottom, 1,000 feet below the surface. She is suspended in the crushing dark, subjected to forces that would flatten a city bus. And she is perfectly still. There is no slipping. There is no uncommanded descent. The depth gauge is frozen at 300. The needle looks like it is painted on the dial. Blount walks over to the ballast control panel. He puts his hand on the red lever for the emergency blow. He doesn't need to pull it. He knows it will work. He knows because he watched the tests. He knows because the valves have serial numbers he has memorized. He looks at his crew. They are not cheering. They are working. They are checking gauges, logging pressures, monitoring the reactor. They have mastered the fear not by ignoring it, but by engineering it into submission. Very well, Blount says. We have certified test depth. Bring her up to 400 feet. As the Permit rises, shedding the weight of the ocean, Blount realizes that Admiral Rickover was right. The limit wasn't the steel. The limit wasn't the reactor. The limit was their own arrogance. They had tried to conquer the ocean with boldness, and the ocean had slapped them down. Now they were negotiating with the ocean using the language of physics and respect, and the ocean was letting them pass. The legacy of the USS Permit and the USS Thresher is written in the statistics of survival. Between 1915 and 1963, the United States Navy lost 16 submarines to non-combat causes. Accidents, flooding, and structural failures. It was accepted as the cost of doing business in the deep. On June 4, 1963, the SUBSAFE program was officially born. Since that day, the United States Navy has certified hundreds of submarines. They have conducted thousands of deep dives. They have spent millions of hours at test depth. And since 1963, not a single SUBSAFE certified submarine has ever been lost. There was one exception, the USS Scorpion, lost in 1968. But the Scorpion was not SUBSAFE certified. She was a pre-programmed boat sent to sea with a waiver to save money. Her loss only cemented the doctrine. No certification, no deep dive, no exceptions. The principles forged in the panic of the Permit's control room, objective quality evidence, independent verification, the obsession with traceability, escaped the boundaries of the Navy. They migrated to NASA after the Challenger disaster. They moved into the civilian nuclear power industry. They became the bedrock of modern safety engineering. Commander Richard Blount retired as a Rear Admiral. He never spoke publicly about the uncommanded excursion of 1963. The logbooks remained classified for decades. But every time a modern Virginia-class or Columbia-class submarine slides into the water, it carries his DNA. It carries the memory of the 5 seconds when the physics stopped working. The ocean remains as hostile today as it was in 1963. The pressure has not changed. The cold has not warmed, the darkness has not lifted. But we have changed. We learned that we cannot beat the deep with courage alone. We have to beat it with truth. As the Permit steamed back toward port in 1964, cutting a clean wake through the winter Atlantic, the crew understood that they were not conquerors. They were guests. They had been granted permission to survive by the laws of physics, and they would never again take that permission for granted. The rules of the deep never changed. We finally learned to read them. The story of the USS Permit is a terrifying reminder that the line between a triumph of engineering and a catastrophic failure is often invisible to the naked eye. It lies in the microscopic structure of a metal crystal, in the freezing point of a gas, in the discipline of a welder on a Friday afternoon. We often glorify the right stuff, the bravery of the pilots and captains who push the envelope. But the Permit teaches us that bravery is not enough. In the face of the absolute forces of nature, bravery is just a spectator. What saves lives is the relentless, boring, obsessive pursuit of quality. It is the paperwork. It is the inspection. It is the refusal to accept good enough. The men of the Thresher paid for this lesson with their lives. The men of the Permit paid for it with their innocence. Because of them, thousands of sailors have gone into the deep and come back home to their families. They are the silent guardians of the standard, the proof that while we cannot conquer the ocean, we can, with enough humility, learn to survive it. Thank you for spending part of your day with us to uncover this hidden chapter of naval history. If this deep dive into the limits of human engineering meant something to you, we'd be honored to have you with us again. Until next time, stay curious and take good care.